The overall goal of this procedure is to separate the sulfate anions from competitive aqueous solutions by selective crystallization with a Bis-Guanidinium ligand synthesized in a single step from simple precursors.
Sulfate separation from competitive aqueous solutions is challenging due to the strongly hydrophilic nature of this anion and typically requires complex receptors that are difficult to synthesize and purify. The main advantage of this technique is that it combines the in situ ligand synthesis and anion separation into a single step.
To begin the in situ procedure, add 10 milliliters of deionized water to a round-bottomed flask equipped with a magnetic stir bar. Then, add 0.067 grams of terephthalaldehyde and 2.2 milliliters of a 0.5 molar aqueous solution of iminoguanidinium chloride. Stir the solution for 4 hours at 20 degrees Celsius. This will yield a slightly yellow solution of big chloride. Once the stirring is complete, add 0.5 milliliters of a 1 molar aqueous solution of sodium sulfate. This will precipitate out 1,4-benzene bis-iminoguanidinium sulfate as a crystalline white solid. Next, utilize vacuum filtration to recover the big sulfate. Wash the recovered solid on the filter paper 5 times with 5 milliliter aliquots of water to obtain the pure sulfate salt. Using powder X-ray diffraction, check the phase purity of the crystalline big sulfate as described. For ex situ synthesis, first set up a 50 milliliter round-bottom flask with a stir bar and hot plate. Add 20 milliliters of ethanol. Next,